Hello everyone, my name is Vedant Bani and today I will be presenting my topic integrating curriculum learning with K-means, a data-centric approach to faster clustering. This topic I have taken from IEEE website which is published by Gakon University, South Korea. So now the introduction of the topic. As we know, K-means is one of the most widely used clustering algorithm in data mining and machine learning. It groups similar data points into clustering based on their distance from cluster center called centroids. However, the main drawback of traditional k-means is its high computational cost, especially for large data set. Every data point is compared to every cluster center multiple times, leading to heavy processing and slow convergence. To solve this, the author proposed integrating curriculum learning into K-means. Curriculum learning is inspired by the way humans learn, starting with easy first and then gradually moving to complex one. By using curriculum learning, data can be sorted based on complexity before clustering, making the overall process much faster. So the next that is the problem in traditional k-means. So let's discuss the limitation of the traditional k-means algorithm. Firstly, it processes the entire dataset without considering how complex or simple each data point is. Some data are already natural clustered. For example, many entries in the dataset may share very common attribute, but k-means still reprocesses them, leading to unnecessary calculation. Secondly, this causes slower convergence, meaning it take more iteration for k-means to stabilize. Now, next, the k-means also struggle when the data are unevenly distributed. For example, when one cluster has very larger number of samples while other have very few. Overall, this issue can make k-means inefficient for large real-world dataset. So now the proposed curriculum learning integrated k-means. So the proposed solution integrates curriculum learning into k-means. Here how it's work. The data are first evaluated and sorted based on their complexity using curriculum learning. The dataset is then divided into two parts, easy and the complex data. The easy portion, which is already naturally clustered, is bypassed, meaning it does not go through k-means. Only the complex portion is proposed using k-means. This significantly reduces the number of iteration and distance calculation. In experiment, this integration led to over 80% improvement in clustering speed while maintaining the same level of accuracy. So now the implementation procedure of curriculum learning integrated k-means. Here you can see the flowchart and now the data processing. It usually handles missing values and outliers. Here complex. There are data divided into two parts, complex and easy data. So the clustering step, it result merging both part are combined to form final clusters. This workflow ensure that only the necessary computation are performed, saving both time and memory. So now we can take a real life example to understand it better. Customer segmentation. Let's take a imagine an e-commerce company that wants to group its customer based on their buying habits. Using traditional k-means, the algorithm process every single customer record, even those that almost identical, like thousand of users from India, male, which has age 25 to 35, and they are the frequent buyer. So we can skip them. Then it only applies k-means to the complex or the rare pattern, like USA female 45 rare buyer, which is a rare buyer. So we can apply k-means clustering in this data. So it result it about 80% faster with almost no loss in accuracy. This approach is especially beneficial in industries like marketing, healthcare, and social analytics, where large data sets are common. So, to solve this, we can use these formulas. Here, we can first calculate the inertia of the data. It measured the compactness of the clusters, and secondly, we calculate the Szilard score, which is also known as SS, which measures how well separated the clusters are. It for the formula is SS is equal to B minus A divided by max of A by B. And thirdly, we calculate the DBI index, which is a lower value is equal to bet. If the value is lower, then it is better clustered. Fourth, we calculate the computing time, which is the time end minus time start. And last, the formula used is iteration count, which is iteration is equal to count. So the advantages of this is faster clustering, lower iteration, reduce computational cost, better resource utilization. Faster clustering, it reduces computation time by skipping already clustered easy data. In lower iteration, the number of centroid updates and distance computation is much lower. In reduced computational cost, this approach saves up to 80 to 85% processing time compared to normal k-means. And in better re- resource, it's ideal for large dataset and system with limited computing resources. So in short, this approach is efficient and scalable. So now the conclusion of this presentation. Uh, the curriculum integrated K-means method provides a smart data-centric improvement over a traditional K-means clustering. By identifying and skipping naturally clustered data, it achieves faster execution with minimal computational overhead. This hybrid approach effectively combines artificial intelligence through curriculum learning with the classical machine learning through K-means. Overall, it's a great example of how data-centric AI can improve existing algorithm with sacrificing accuracy. Before I conclude, I would like to take a moment to express my sincere gratitude to the authors of the research paper that inspired this presentation, Professor Abdul Majid and Professor Huang from Gakon University, South Korea. Their paper integrating curriculum learning with K-means, a data-centric approach to faster clustering, represent an excellent contribution to the field of data mining and machine learning. The way they merge traditional algorithm like K-means with modern AI concepts such as curriculum learning and shows remarkable innovations and practical understanding of real-world computational challenges. I truly appreciate the clarity and depth with which they presented their ideas. It not only improved my understanding of clustering but also helped me realize how data centric thinking can optimize existing algorithms. Their work has inspired me to look deeper into hybrid approaches that connect classical method with intelligent adaptive learning strategies on behalf learning strategies. On behalf of all of us, I sincerely thank Professor Majid and Professor Awang for their valuable contribution and for paving the way for future research in intelligent clustering systems. Thank you, everyone.